Welcome to the online uh, lecture series on the certificate course on data analysis under the UGC style stream. I am Dr. Kalpesh Amrutkar, Assistant Professor in Department of Statistics, KTHM College, Nasik. Friends, uh, in previous two lectures, we have seen that uh, some non-parametric tests. Basically, in previous lectures, we have seen the why we study the non-parametric tests. What is the objective of non-parametric tests? Their advantages and some basic but very well-known non-parametric tests. Which is generally used for the non-normal data like the Dunn test, sign rank test, Kruskal values test. Uh, in today, we will see the very necessary test, that is very useful test, Kolmogorov-Smirnov test. Kolmogorov-Smirnov test is two types. That is, the first one is the goodness of fit, and another one is the test for the comparing two populations. So, friends, firstly we will see the Kolmogorov-Smirnov test for the goodness of fit. So, in objective of this test is the to test the population distribution, that is the capital F of x, which is generally capital F of x is denoted for the cumulative distribution function, which is already seen in the probability lectures. So this f of x be regarded as f naught x. This f naught x is just the based on the random sample. So here we will consider the xi, that is the I running from 1 to n, that means x1, x2, xn is the random sample of size n, which is drawn from the population, and here we will assume that this f naught x is the cumulative distribution of a specified or that given population. This means this f of x, simple, this f of x is just the distribution function of random sample, and f naught x is the cumulative distribution function of that given population. Okay, so here firstly we will define the hypothesis. So first one is the null hypothesis, that is the population distribution f of x is f naught x, because our objective to test the our random sample is coming from that particular population or not, that is our objective. So here null hypothesis is the population distribution f of x is f naught x, that means your sample is coming from your assuming particular distribution. Okay, but in similarly alternative hypothesis is the population distribution f of x not f naught x, that means your random sample is not belong to your that particular population. Okay, so further we need the alpha, that is the level of significance, and based on this level of significance we will find the critical value, or we can say that that is the table value. So this value for that particular sample size and your level of significance is obtained from the table, and with this table is already provided in the your statistical table. Maybe the table number 9 is available in your statistical table. You can see this, and we can find the table value. Okay, so we will see the procedure of case test, means how to perform the Kolmogorov-Smirnov test for goodness of fit. So firstly we will calculate the cumulative distribution function based on the sample observation and your specific population distribution. Okay, that means in generally we will see in the chi-square test, this case test goodness of fit is equivalent to the chi-square goodness of fit. Chi-square goodness of fit is the parametric test, but Kolmogorov-Smirnov goodness of fit test is the non-parametric test. So with these two tests are equivalent. So whenever you will perform the chi-square test, so that time you will you have find out the observed frequencies as well as expected frequency, and then we will compute the differences of observed and expected like this. So same procedure, same wise procedure here. Only here we will find out the distribution function for the random sample and your given population. Means here we will use the empirical distribution function. In parametric test, that is the chi-square goodness of fit, you have to use the direct parametric means distribution function or whatever their observed or expected frequency there. Here we will use the empirical distribution function. Okay. Further, we will find the cumulative distribution of the sample fnx with the empirical distribution function, and which is defined as a step function. Already I have mentioned that is the empirical distribution function, and which is generally denoted as fnx is equal to number of observations, that is xi is less than equal to x. How many observations are less than equal to x? There x is this small x is a pre-defined value, whatever this x. So this number of observations are less than that particular x divided by total number of observations, that is your fnx. Suppose only one observation is less than this x and we have the 10 observations, so 1 by 10 is the f1x, like this, how many number of observations are there. So like this is the empirical distribution function. Further, we have the population cumulative distribution function, and this is the empirical distribution function. So we take the absolute difference, and if you have to find the maximum value of this absolute difference, this is your test statistics, that is generally denoted by D. Okay, so if our D, that means this calculated value, test statistic D calculated value is less than equal to your table value, that is the D alpha, which is also known as critical value. So we fail to reject the H naught, that means we accept the H naught, and if your D is greater than alpha, then we reject H naught. Okay, or we can say that we accept your alternative hypothesis. Okay, so we will see the case test through one simple example. Suppose we have the random sample of size 20, there means we have the 20 observations are there, and we want to test these observations is coming from the standard normal distribution or not. That our objective, means we want to test whether the sample comes from the standard normal distributions or not. That is our intent. So our null hypothesis should be defined as the given sample is drawn from a standard normal population, and alternative hypothesis, the given sample is not drawn from a standard normal distribution. So here we assume that level of significance, that is alpha, is equal to 0.05, and that corresponding critical value for the 0.05 and your 20 number of observations is 0.294. We can see in the table value. In statistical table, there are table is available for separate table is available for case test for goodness of fit. Okay, so this value is come from that particular table, that is 0.294. Now here we have the observation like this. These are 20 observations. So firstly we arrange this observation ascending order. Okay, increasing order, this observation is arranged in increasing order. Okay, so further your f naught x is calculated. So this f naught x is your value. Sorry, here the 0.7523. These are the typing mistakes is there. So this observation is like this. Okay, so how this value is coming? So this value, that is the distribution function of this your, means this x is probability of x is less than equal to minus 1.152. This is the standard normal probabilities are there. Okay, this is the standard normal probability, and this fnx means this is the our, because our interested in the standard normal distribution, so that's why these probabilities are the standard normal distribution probability. Okay, and this fnx, that is the empirical distribution function. So first observation divided by this increasing order you have assigned. So first 1 divided by 20. This again, this observation has chance 1 by 20, but this and this plus. So this is the distribution function. So you can add like this probability. So 2 by 20, 3 by 20, like this. These are the your empirical distribution function. If you have to subtract this 0.1247 minus this 1 by 20, that means maybe 0.005. If you have to subtract from there, we get the 0.0747, and this is the absolute difference. Okay, so these are the absolute difference, and maximum of this column, if you have to find the maximum value of this, we get the 0.0946, and this is our test statistics. So 0.0946, this value is less than the 0.294. So therefore D is less than D alpha, that means calculated value is less than table value. So we say that we failed to reject H naught, that means we accept H naught, and our H naught is that the given sample is drawn from the standard normal distribution. That means we can say that the given observations or given data is coming from the your standard normal population. Okay, so this is the simple example for case test for goodness of fit. Now for second test is case test for comparing two population. Okay, same way in chi-square test there are two tests are there: chi-square goodness of fit and chi-square independent test. So same way here case test for independence. Okay, so here our objective is that this to test the two population distribution are identical based on the two sample distribution. If you have the two independent sample and our interest, so both sample have coming from the their separate distribution, and these distributions are independent. Okay, so suppose we have assumed that we have the x1 x2 xn observation with the random sample of n observation we are drawn from a population, and let y1 y2 yn with the random sample of size n from another day population. Both population is different and which is identical. Okay, so first step we will define the our hypothesis. So null hypothesis is that the H naught is the two population distribution are identical. That means there is no significant difference between the two sample distributions. Both the distributions, both the population distributions are different. Okay, and alternative hypothesis is the two population distribution are not identical. That means there is a significant difference between two population sample distribution. That means the that samples coming from that population has significant difference between both the population. Okay, so same way in the case of goodness of fit, we have find the D alpha, that is the critical value based on the your level of significance based on the your sample size. Here sample size is same in the both the populations. Okay, they are same okay, or maybe if your sample size is different like this k or y1 y2 x1 x2 xn1 and y1 y2 yn2, so no problem, we can find out this. Okay, we will see in one example, simply example we will see. Okay, so firstly what is the procedure for the case test for two population is firstly calculate the cumulative frequency for each observation, that is xi, and which is denoted as c of x, and from yi this cy. Okay, so after finding the cumulative frequency, we will obtain the cumulative distribution of the two sample, that is fnx and fni, which is the empirical distribution function of the your random sample x and y respectively. So fnx means the number of observations xi which is less than equal to x divided by total number of observations. Same way fny is the number of observations, that is yi is less than equal to y divided by total number of observations. After finding this cumulative distribution function for the both sample, we will take the absolute difference between these two cumulative distribution function, and test statistics is here d is equal to maximum of, this is the here we will be the printing mistake is maximum of this absolute difference. The test statistic is same, just the maximum of fnx minus fny. And so our conclusion is, if your calculated value is less than equal to table value or your critical value, then we fail to reject H naught, and if D is greater than your critical value, then we reject H naught or accept alternative hypothesis. So we will see case test for two population by one simple example is, that is, we have the data of the lifetime of bulbs of two different brands. There are two different brands are there, and their tube or whatever the electronic gadget has the average life is there. So brand 1 has 7 observation and brand 2 has 8 observation. Okay, so our null hypothesis is the average lifetime of these two brand of bulbs are equal, and alternative hypothesis, the average lifetime of two brands of bulbs are not equal. Okay, and level of significance, that is alpha is equal to 0.10 and critical value is 0.10. For the n1 is 7 and n2 is 8, and the critical value here also, this critical value is that is this value is just 0.53. okay, this is the 0.53 value is there. Okay, so please be careful, this is the 0.53 value is there. Okay, now further we will find the cumulative distribution function. So suppose we have this values, which is the combined observations for this. We are all these observations, that is the brand 1 and brand 2 are combined, and arrange this observation in the ascending order. So total observations are 15. Okay, we have the total observation 3, 6 and 11. Okay, so these are the total observations are there. Some observations are repeated, so that's why we are not writing here. These observations already carried in your cumulative distribution function. Like means this 70 is coming from the brand 1, so therefore f of x is 1 by 7. 70 is not belonging to the brand 2 observation, so therefore this value is 0. 80 is belonging to brand 1, so therefore this 1 by 7 plus 1 by 7, that is 2 by 7. 80 is also belonging to the brand 2, so therefore this is the 1 by 8 probability. Similarly, we can find this like this, and their absolute difference is calculated here. So the maximum value of this absolute difference is 13 by 28, that is the 0.4643, and this calculated value is less than the critical value. Already we have told that the critical value is 0.53. So we fail to reject H naught, that means we accept H naught, and we conclude that the average lifetime of two brands of bulbs are equal. Okay, there is no significant difference between these two brands, average life of these two brands. Okay, so these are the Kolmogorov-Smirnov test. Okay, so in today's lecture we have seen that Kolmogorov-Smirnov goodness of fit test as well as Kolmogorov-Smirnov test for the two independent sample tests. Okay, so these are the very simple tests are there for the non-parametric test, and which is the very useful when you have to analyze the any non-normal data or any type of data. We will handle it. So we use the Kolmogorov-Smirnov test, very useful, and most of the time this test is used for the design of experiment or many statistical applications for this case test is there. So we will use it. Okay, so thank you so much.